Hey guys, BuildZoid here, and today we're going to be taking a look at the MPG Z690 Carbon Wi-Fi motherboard. So this motherboard was provided to me for review and testing by MSI. So thank you to them for providing the board. And as of making this video, the board tends to go for around $400, at least according to Newegg. So yeah, anyway, let's get into it. Now, the motherboard does have a postcode, which obviously I'm a big fan of. Like that's the part that was important to me when MSI was like, "Hey, BuildZoid, what motherboard? Like, here's a choice of motherboard. Which ones would you like to test?" At the time, the Unify X wasn't available, so I hope to get the Unify X in the future. But yeah, basically, I had the option of like the Carbon, and I think the full size, like the 4DIMM Unify, which is very boring in my opinion, and then I think the Tomahawk as well. But out of those boards, this is the cheapest one to come with a postcode, so that's the part I care about. But this is not that cheap a board. As I said, it goes for around $400. And the reasoning for that is that the sort of focus of this motherboard's functionality is expansion options. So right off the bat, you get 5 M.2 drive slots. So you get one over here attached to the CPU, then you get 2 over here, and then another 2 down here. So you get 5 M.2 drive slots. One of them is PCIe Gen 3.0 by 4 and is shared with one of the SATA ports. So you can either have the M.2 slot or you can have that SATA port. You can check the manual for which one it is. But yeah, at this price point, I think this is the largest number of M.2 drive slots that you can get on a Z690 motherboard. So I guess if you're into M.2 drives, that's pretty cool. I personally don't really care. I'm perfectly happy with SATA speeds, but yeah, most people these days prefer having M.2 drives. So, you know, if you want a ridiculous number of M.2 drives attached to your motherboard, this motherboard does a very good job of doing exactly that. But the other and arguably far more expensive thing that MSI has done sort of to give you a lot of expansion options and flexibility is they've split up the PCIe lines from the CPU. So on the vast majority of Z690 motherboards, especially at this price point or below this price point, you get exactly one Gen 5 PCIe slot, and that's this one, and it's going to be running at X16 constantly. Now on this board, this slot can go both X16 and X8, you know, it's Gen 5. And then MSI, and then thanks to a bunch of switches on the back of the board, which is these chips over here, which incidentally, these are BGA PCIe switches. BGA. Like, that is not cheap. Like BGA is not the cheapest of packaging technologies. So yeah, like the $400 price point for this board makes sense. And there's other things that have gone into getting that second X8 Gen 5 PCIe slot, but that's a big part of it. So basically, this is what the cheapest board that I'm aware of that'll actually allow you to connect 2 different PCIe cards directly to the CPU. The board does not have an SLI license, which is normally what you would want to use this kind of thing for, but then again, SLI is basically dead these days, so that's not really a big deal. However, AMD Crossfire does work, even though AMD has kind of ditched support for it. Like, if you use old enough drivers, it'll still work properly. Yeah, so that's kind of what I'm maybe going to be doing with this board, is running like 2 old AMD GPUs in Crossfire on it with the 12900K for like various 3D benchmarking. But otherwise, what this does give you the option to do is an absolutely stupid number of M.2 drives, because you can put 5 M.2 drives onto the board itself, but you can put another 2 M.2 drives into that X8 Gen 5 slot, and you'd still have PCIe lanes left over for your GPU. Oh, and let's not forget the last PCIe slot on the board, which is this one down here, which is PCIe X4 4.0 coming off of the chipset. You could put another M.2 drive on that. So the absolute limit of how many M.2 drives you could put on this board is 8. Not that I would personally do that. I would probably go with like you know, well, some silly multi GPU setup, but yeah, like the board gives you a lot of expansion options, and that's, you know, what's really expensive about this, because you've obviously got the PCIe Gen 5 switches, but other than the PCIe Gen 5 switches, you also have the fact that the motherboard now has an 8-layer PCB, and Yeah, that's not cheap. Like, historically speaking, 8-layer PCBs were reserved for motherboards around the $400 to $500 price point. So this motherboard really isn't, like this motherboard doesn't drastically change that. It's a $400 board with an 8-layer PCB, which is roughly what you'd expect a 8-layer PCB motherboard to cost. Yeah. But then also you have like the Gen 5 PCIe on here. So that's kind of that's why this motherboard costs as much as it does, is because, yeah, MSI basically decided to give you a rather expensive but neat expansion options with the two X8 Gen 5 PCIe slots. So anyway, let's move on to the rear I/O, where we have a BIOS flash button, so you can update the BIOS of the motherboard without even having a compatible CPU. Then we get a decent number of USB Type A. There's 9 of them. You get HDMI and DisplayPort outputs for the iGPU. You get Intel 2.5 gig LAN, a Type C port, and Wi-Fi 6E from Intel. So yeah, that's the rear I/O, and pretty standard. I mean, again, personally, I love USB ports, and I think 9 is still well within what I'm. I don't think 9 is too little for me, but yeah. So that's the rear I/O. Like, at least, like, we've got 8 of them at the very least, which I think is like a good starting point for. Like, we've got more than 8 of them, which I think is a decent starting point for an ATX motherboard. Anyway, so that's the rear I/O. And now I guess we get to talk about the power delivery, because there's really not much else that this motherboard is doing, right? Like, yeah, you get the postcode, you get some troubleshooting LEDs, but there's no safe boot button, no onboard buttons whatsoever. Oh, I guess you do get a LED on-off switch down there. And of course, there's a clear CMOS jumper right there, the JBAT1. Anyway, let's talk about the power delivery. So, power delivery-wise, we have another VRM that's perfectly capable of powering anything that you can put into the LGA 1700 socket. Partially because LGA 1700 CPUs are much harder to cool than their predecessors, so it's kind of hard to get them to pull as much power. And VRM is split up like that. So we've got an 18-phase V-core, and it is actually 18 phases because that is a RAA 2291 31 voltage controller, so that's a 20-phase controller from Renesas. MSI is running it as 18 plus 1. The plus 1 goes to the iGPU. Then down here we have the VCC in phase, and that is controlled by this chip over here. That is a Monolithic Power Systems MP2960, which is running in one-phase mode, but it is a two-phase controller. So it's a two-phase, but it's running in one-phase mode. So, yeah. So it runs as one. I guess I should do like whatever. Screw it. It's a one. Like, it's a single-phase VCCN running off of a two-phase controller. Anyway, so yeah, V-Core is 18 phases. This is sort of the standard high-end voltage controller for Z690 motherboards, so nothing too surprising there. For the power stages, MSI is opting for RAA 220075s. Now, these are 75 amp smart power stages. So being smart power stages, they integrate current monitoring, temperature monitoring, and a bunch of safety features. However, at 75 amps, they're not as efficient as some of the other ones that, like, say, the last motherboard we looked at, which was the Z690 AORS Pro, that was on 90 amp smart power stages, also from Renesas, because Intersil is owned by Renesas. Those were somewhat more efficient than these are. These don't really go past the 94% efficiency mark, whereas the 90 amp parts that we were looking at last time, those do go over 94%. However, MSI is using 2 power stages more here. They also have an 8-layer PCB, so your power plane losses are going to be reduced. The PCB is also going to act as a better heatsink because it just has more metal in it since it has a higher layer count. Then also having more power stages means that the heat that they do produce is spread across the power stages more evenly. Well, not more evenly, but it's spread across more power stages, so you just get less heat per component, therefore potentially lower temperatures. Even though this VRM is efficiency-wise not exactly, like, this isn't better than the VRM that we had on the Z690 Aorus Pro in terms of theoretical efficiency. Overall, it might actually still win just because of the extra PCB layers for the power plane, but yeah, and also you could have like differences in the inductor selection between MSI and Gigabyte and that kind of thing. So it's hard to say for sure because this VRM is not that different in terms of efficiency from the 16 phase that we were looking at in the Z690 Aorus Pro video. Either way, this 1.2 volts output voltage and 500 kilohertz switching frequency should, like the power stage and inductor heat output should be for 200 amps about 17 watts of heat, which is slightly less efficient than what we had on the Z690 Aorus Pro, but that is still perfectly good efficiency for powering anything that you can put into the LGA 1700 socket. Same goes for 300 amps output, where it hits about 26 watts of about 26 watts of heat dissipation from the inductors and power stages. And the motherboard does have a heatsink that syncs both the inductors and the power stages. Though I forgot to take a picture of the heatsink. Not that it really matters that much, I don't think. Like, the thing is, the board also has just an 8-layer PCB, so that helps. Then 400 amps output, the VRM is going to be producing about 37 watts of heat. Like, it's going to be more, I do plan to do practical testing on this motherboard. I've just not gotten around to it yet, because the CPU I have is from Gigabyte, so, that makes it kind of awkward to use the CPU with MSI boards. 500 amps output, it should produce about 52 watts of heat from the inductors and power stages. So in the current range that we actually care about for LGA 1700, which is 200 to 300 amps, the VRM will have no issues powering anything you can put into the socket. It might run a little bit warmer than some of the motherboards that use like 90 amp smart power stages, but it won't overheat. Like that's kind of the thing, is just like, as long as the VRM is below like 100 degrees Celsius, it really doesn't matter what temperature it runs at. And I would say 100 degrees Celsius in my like zero airflow torture test style tests, because like, it's kind of funny for me to see other motherboard reviews, and like most motherboard reviewers get temperatures that are like 20 degrees below what I get, which is just like, okay, evidently I am very mean to my motherboards. But anyway, yeah, so this VRM should really have no issues powering a, well, 12900K, 12700K. It doesn't matter, right? Like, you're going to run out of cooling on the CPU before you run out of power delivery, and that's, all you really need for overclocking. So, yeah, that's the V-Core. Then for the iGPU, we've just got another RAA 2200775. And then for the VCCN, since this is a monolithic power system, is it power system? Monolithic, yeah, it's a monolithic power systems controller. That is their name. I might have forgotten it. It's not in my notes. Oh well. Anyway, for VCCN, we have a MP 8799 2 70 amp smart power stage. So Intel actually, like, I finally got my hands on the Intel design guidelines for LGA 1700. And according to Intel, the maximum output current for VCCN is 33 amps. So this is perfectly adequate for handling the VCCN rail, because at 40 amps output, that power stage is only going to be producing about 4 watts of heat, and, it's under a giant VRM heatsink. So as long as the, like, V-Core VRM isn't running super ridiculously hot, this phase should have no issues. Like, the thing is, this is going to have much less impact on, like, this isn't going to run as hot as the rest of the VRM is, because this just doesn't have to do as much work. So yeah, it makes perfect sense that, MSI opted for a single-phase VCCN, because I've seen quite a few motherboards that actually have a two-phase VCCN, and, now that I've seen the Intel design guidelines, I really think that that's just kind of unnecessary overkill. But, it also, like, basically all that means is this is fine, and the other motherboards, it's like, that's more fine, not really. Like, it doesn't work like that. But, yeah, so that's our VCCN phase. We've already talked about the iGPU. Now then, for the capacitor configuration, we've got MSI has a really, like, light input filter in terms of bulk capacitance. So you've got two bulk caps over there, two bulk caps over here. They're spread around the power plane to, deal with the current draw from the power stages. Like you will see some motherboards where they have all of their bulk capacitance over here, but then what that leads to is that you have like a lot of ripple by the time you get to the power stages all the way on like the other end of the power plane. Whereas with this sort of more even distribution, you get better, like you have less it means the switching noise across the power plane is a bit more equal because the filtering capacitors are spread across the power plane more evenly. Yeah, MSI doesn't really use a ton of bulk capacitance, which is fine. Like CPUs, like if this was a GPU, I would say, okay, this is not fine. You can't have four 270 microfarad bulk caps for your input filter on a GPU, but this is not a GPU. This is a CPU. CPUs really aren't that noisy. You don't need a ton of input filtering capacitance, even though like these days we do see a lot of motherboards that like from Asus, ASRock, and Gigabyte, they like to throw a lot of capacitors on their input filters. ASRock especially likes to have elaborate input filters, partially because they've ditched the input filtering inductor on a lot of motherboards. But yeah, like ultimately, I don't see an issue with this. Though it is just kind of interesting that MSI is opting to have far less bulk capacitance than most other manufacturers. And the same goes for the output filtering, actually. Like we're just going to check on the back. Yeah, okay, I did highlight it properly. Like the bulk capacitance for the V-core, well, I guess we can do it this way, is just, these 5 capacitors over here and then these 3 over here. These 2 are for the iGPU phase and these 2 are for VCCN. And this is standard. Like VCCN normally has 2 560 microfarad bulk caps, and the same goes for the iGPU. But the 8 capacitor V-core is, like, that's very small compared to a lot of other motherboards. Like, you'll see a lot of motherboards have a lot more bulk capacitance than that. However, this has been kind of the norm for MSI motherboard like power delivery designs. And when I was doing Z490 transient response testing, this didn't really like the only downside to this was that you had somewhat more overshoot, which is like, yeah, it looks ugly on the oscilloscope, but it doesn't actually affect overclocking performance, so it doesn't matter. So yeah, like interesting, like interesting design choices to just have sort of less bulk capacitance than most other manufacturers do on both the input and the output. Though also in terms of like what performance impact this has, in my past experience testing MSI motherboards, it barely makes it. Like it really doesn't have any negative side effects. So yeah, I don't see an issue with that. All of the capacitors are from Nippon Chemicon, and they're rated for 10,000 hours 10,000 hours at 105 degrees Celsius. And then for the actual CPU socket filtering, the back of the socket is very empty. And the front of the socket is actually fully populated, but the very empty CPU sockets are also a very standard MSI thing. So, like, MSI VRM designs are kind of interesting that they have very low capacitance compared to, well, most other manufacturers, both in terms of what they put into the socket, what they put on the input, what they put on the bulk output filtering as well. And the funny thing is, like, I've not been able to measure any massive downsides to MSI's, approach to doing power delivery like this. So yeah, and I don't really have any plans for doing 12th gen oscilloscope testing, because when I did that on Z490, it was a total waste of time because all of the motherboards basically perform the same. It is worth noting that MSI does put a hole into the CPU socket, so if you were using this motherboard for LN2 overclocking, you could put a K-type thermocouple through there, though I'm not sure if 12th gen has any specific voltage requirements that this motherboard may not be able to handle, like may not, give you access to in the BIOS. I wouldn't expect that to be, like, MSI is usually pretty good, actually really good about having a, well, that's not entirely true. Like, for some reason, for a lot of DDR motherboards, they wouldn't have VTT DDR control, which is really annoying with certain memory chips. But, well, other voltage options, they generally tend to be pretty good about that. So, yeah, anyway, that's sort of the power delivery on this board. So we have a, very powerful V-Core VRM that's perfectly capable of powering anything that you can put into the socket. A rather low capacitance approach to the output filtering, but like it's worked for MSI before. I don't know why it wouldn't work again. So, yeah, I don't see any reason to complain about that. And for the socket, well, that's actually also just like there's less capacitance in the socket than what you see on from most other vendors. So I guess at this point, let's move on to the memory section of the board, which is well, so obviously the board is an 8-layer PCB. I've mentioned that before. I am like 99% sure that the main reason this board is an 8-layer PCB is because of the dual PCIe Gen 5 slots and not because of the benefits it has for memory topology. But you can't deny that like there could be some advantages to the memory topology by having 8 layers instead of 6. So yeah, we have an 8-layer PCB. Then it is a daisy chain layout. So you're going to want to, or not going to want to, you have to use these slots first because those are the ones at the end of the chains. And the board even tells you as much. If you use the other slots, you're going to have a really bad day in terms, like, it might not boot, and if it does boot, it'll overclock like trash. So yeah, do this. Don't put your first set of dims into the like nearby slots. Anyway, other than that, daisy chains just generally prefer if you populate only the slots at the ends of the actual chains. I don't know if this topology is any good. Again, it's really early into DDR5 life cycle, so I've not had a ton of DDR5 overclocking experience. I don't know what's good. I don't know what's bad. I just know that this is an 8-layer daisy chain. And it is shielded, right? We can't see any of the data traces running over the top layer of the motherboard or the back layer of the motherboard. In fact, we can't even see some of the command address bus that you can see on some of the lower layer count boards on the back of the board, though. We can see, I think, we still see a lot of it on the front of the board, right? Like you have all of these traces over here. Actually, maybe MSI jammed all of the command address bus onto the top layer. I'm really not sure. It's not like I have it's not like motherboard vendors are going to send me, schematics of like, yeah, this is where everything, no. Especially not for the memory topology, because that is one of the places where a lot of research and development effort goes into, just optimizing the memory trace layouts. But other than that, as is the norm for DDR5 motherboard, we've got SMT DIMM slots, which just help with high-speed signaling because they have better parasitic properties than the through-hole DIMM slots. And yeah, that's it for the Z690 Carbon from MSI. Like, is this going to be a good overclocking board? Yes. Actually, I forgot to mention that you do get dual 8 pins, and MSI is using the high current variant of the power connectors, right? Like we've got solid pins right here, not the folded metal ones. Also got a solid pin 24-pin power connector, which again, makes it a little bit harder to unplug, but on the other hand, the connector can handle more power. So, yeah, that's that. You don't need to plug in both 8 pins. I am really surprised that they labeled this one CPU power 1 and this one CPU power 2, because if I had to guess, the 12-volt power plane this is closer to that than this is. Like, if you plug this one in, the current will have to travel this much distance instead of this much distance. Not that it'll make a huge difference, right? Like, it does. Literally, like, that's not going to make much of a difference whatsoever, but I would have used I would have labeled the nearest connector to the VRM as the actual power one. But anyway, yeah, you can plug in either of them. The motherboard shouldn't complain about that. And you also don't need to plug in more than one of them. It is very, very hard to get a 12th gen CPU to pull more power than what a 8-pin power connector can handle. Because even on 18 gauge cabling, like these connectors can do over 400 watts of power when you have the high current variant of the connector. So yeah, you really the dual 8 pins is totally unnecessary. You can use just one of them. If your power supply doesn't have dual 8 pins, you don't have to worry about that. Anyway, yeah, that's it for the MSI Z690 Carbon Wi-Fi motherboard. Basically, if you love M.2 drives, this is a really solid option for that. If you have any kind of requirement for multiple PCIe cards connected to the CPU, it's a really solid option for that because it's kind of the cheapest option to do that. And it's not like MSI is not, I guess you could argue that they're spending less on bulk capacitors for their vCore VRM than the other vendors are. But also, if it performs just fine, which historically it has, I don't really see like any downsides to this. You know, so yeah, just a like the thing is, it is still a $400 motherboard, right? Like this is not a cheap motherboard. So I really think if you don't need the expansion options that this offers, there's not much point in getting it. But yeah, if you do need the expansion options, then this is kind of the cheapest ways to get them, right? So yeah, that's the Z690 Carbon from MSI. And so thank you to MSI for sending over the board. That's it for the video. Thank you for watching. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHLC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it'd be much appreciated if you'd check them out. And that's it for the video. Thank you for watching, and goodbye.